Hello everyone, this is Dharambir sir here. So today we are going to continue with chapter 1 of grade 11th maths, that is sets. And the topic of today's video is subsets. Okay, sets and their subsets. So let's start. So first let me explain you what is a subset. So a set, subset means it is also a set. So a set A is said to be a subset of another set B. Okay, if every element of A is also an element of B. Clear? We have two sets A and B, and if every element of set A is also present in the set B, then we say that A is subset of B. And symbolically it is written as, you can see that A is subset B. If A belongs to A implies A also belongs to B. So this is a symbol of subset, that if an element A belongs to A, then it must imply that the element A also belongs to B. Now we denote the set of real numbers by R. I explained you in the previous video. The set of natural numbers by N, the set of integers by Z, set of rational numbers by Q, set of irrational numbers by T. Then we can simply observe that N is subset of Z because all the natural numbers are also in the integers, and Z is a subset of Q because all the integers are also present in the rational numbers. Clear? And Q is also a subset of R because all the rational numbers belongs to real numbers. Then T is subset of R. T is subset of R, but Q is not a subset of T. Clear? And N does not belongs to N is not a subset of T. It follows from the above definition that every set A is a subset of itself because all the elements of A must be in A also. It means A is subset of A. And since empty set phi has no element, we say that phi is subset of every set. Remember these 2 points, that phi, that is the empty set, is the subset of every set, and a set is a subset of itself. Clear? So pause and note down the points. Now let A and B are two sets. So if A is subset of A and A is not equal to B, it means all the elements of A are in B but A and B are not equal, then A is called a proper subset of B. Clear? Then A is called proper subset of B and B is called superset of M. So I am given an example that if A is 1, 2, 3 and B is 1, 2, 3, 4. So you can see that all the elements 1, 2, 3 of set A are also in set B, but these two sets are not equal. So in such case we say that A is proper subset of B and B is superset of A. Clear? Okay. Now if a set has only one element, then we call it a singleton set. If there is only one element in a set, then it is called a singleton set. I hope I am clear. So pause and note down the points. Okay, next we are going to define some intervals as subset of R. R means real numbers. So let AB, elements AB belongs to R and A is less than B. Then an open interval, now look at the definition. An open interval is denoted by small bracket AB. Now remember these brackets, they are very important. Small bracket AB denotes the open interval. Is the set of real numbers x such that A less than x less than B. It means x will be some number between A and B, but it should not be equal to A and B. X is greater than A and x is less than B. So suppose I am saying open interval 2 to 5, 2, 5. It means all the numbers between 2 and 5 excluding 2 and 5. Clear? A closed interval denoted by square bracket AB is the set of real numbers x such that A less or equal to x less or equal to B. Now look at the differences. In open interval A is less than x less than B, and in the closed interval A is less or equal to x less or equal to B. It means suppose I am denoting square bracket 2, 5 again. This time all the numbers from 2 and 5 will be included, including 2 and 5 also. Okay. In the previous open interval, 2 and 5 were excluded, but in closed interval, we include the end points, that 2 and 5 also. The denotation for open interval is small bracket, and for the closed interval it is square bracket. Now point C, intervals closed at one end and open at the other end. Suppose we have closed A and open B, then x such that A less or equal to x less than B. Which side is closed, that will be equal, and which side is open, that cannot be equal. And if open A closed B, x such that A less than x less or equal to B. It simply means the point where the bracket is smaller, that point will not be open, that point cannot be included, and that point where the bracket is closed, the square bracket, then that point will be included. Clear? It's very important, so note down the points. Next we have a new term called power set. Now we have learned about subsets. So the collection of all the subsets of A is called the power set of A. It's very simple. If we have a set A, then we can write its subsets and we can collect those sets, make a collection of those sets. That collection will be called power set. So the collection of all the subsets of any set A is called the power set of that particular set A. Done? The power set is denoted by capital PA. If the set is A, then PA. If it is X, then P X, but capital P. Okay, this one is very important. If the number of elements in A is equal to n, denoted by Na is equal to n, that is number of elements in set A is equal to n, then the number of elements in power set A will be equal to what? 2 power n. Okay, so if a set has n elements, then it will have the number of elements in the power set will be 2 power n. That is, the number of subsets will be 2 power n. And for example, if A is equal to set 1 2, then PA is equal to what? 5 of the subset of every set. Individual element 1 is also a subset of 1 2. Element 2, the set 2 is also a subset of 1 2, and a set 1 2 is a subset of itself also. While explaining the definition, I have told you that 5 is the subset of every set, and every set is the subset of itself too. Clear? So pause and note down the points. Next we have the universal set. Next term. So this is also a set. This is also a set which contains all the elements of different sets. Okay. For example, suppose I am taking that the set of vowels in the English alphabet. For the set of vowels are A, E, I, O, U. Now if I have to define a universal set, then we can write a set which must include all these sets, all these elements. So if we simply like all the alphabets, 26 alphabets in a set, then that 26 alphabet must contain that 5 vowels. So that those 26 alphabets, the set will act as the universal set for that particular set of vowels. It is as simple as that. Suppose I have a set of natural numbers and I want to define the universal set for that. Now think of the set which will contain all the natural numbers. Simply if I write the set of all the real numbers, then all the real numbers contain the natural numbers. Then universal set for the natural number set will be what? Real numbers, or rational numbers, or whole numbers, or integers. You can anything write. It depends on the situation. For the set of, I have given another example that for all the integers, for the set of all integers, the universal set can be the set of rational numbers or the set of real numbers. Okay, it depends on the situation. We have to define a set which must contain all the elements of any other given set. Okay, so universal set is nothing that it is a set which contains all the elements of the given another set. I hope I am clear. So pause and note down the points. So I hope I am clear with the definitions and different points. So let's start exercise 1.3. And the question 1 is, make correct statements by filling in the symbols subset or not the subset in the blank spaces. I have solved 3 parts for you. First is, now you can see 2, 3, 4, and second is 1, 2, 3, 4. Now as all the elements of the first set, that is 2, 3, 4, are present in the second set, then it is clear that this is a subset of, that is 2, 3, 4 will be a subset of 1, 2, 3, 4, 5. Clear? Third is, x such that x is a student of class 11 of your school, and second is x such that x is a student of your school. Now if you are a student of grade 11th of this school, then it is clear that you are also a student of this school, na? If you are in grade 11th of this school, then you are present in the school also. Clear? It means this will be a subset. Okay. Sixth is x such that x is an equilateral triangle in a plane, and second is x such that x is a triangle in the same plane. Now equilateral triangle is also included in triangle. Yes, it means every equilateral triangle in a plane is a triangle in the same plane. Okay, it is clear, it is obvious that the first will be a subset of second. So pause and solve the other sums. Okay, coming to question number 2. Examine whether the following statements are true or false. Okay, it is given that AB is not a subset of BCA. It is clearly false because the elements of first set are present in the second set, though it must be a set. So this will be false. Second, the set A is subset of set ABC. Yes, it is true because the element A of the first set is present in the second set. So it is a subset. So this statement is true. Next we have the set A. Now look at the terms. Set A belongs to the set ABC. Now this is false. Why? Because in the second set ABC, element A is there. Okay, but the set A is not there. Belongs to and subset are two different things. Okay, belongs to means this set must be there in the second set, but the second set contains element A, element B, element C. There is no set A in the second set. So this is false. Okay, so pause and note down the other sums. Moving to question 3. Let A is equal to, now look at the question. A is equal to 1, 2, set 3, 4 and 5. Now the elements of set A are what? 1, second element is 2, third element is set 3, 4, not element 3, 4. Remember this point. It is a set 3, 4 which belongs to A, not the individual element 3 and not the individual element 4. So the set A contains only 4 elements. Element 1, 2, set 3, 4 and 5. So only 4 elements are there. So which of the following statements are incorrect and why? So I have solved a few. First, that the set 3, 4 is subset of A. Now this is false because 3, 4 is an element of A. It is not a subset. Okay. Set 3, 4 is an element. For this to be a subset, if there was a double bracket, double braces were there, then we can say that yes, it was a subset. But since the element 3, 4 is there, so element 3, 4 belongs to it, not the subset. Clear? So this statement is false. Moving to second one. Now set 3, 4 belongs to A. Yes, it is true because it is obvious that the set 3, 4 is there, not the element 3 and not the element 4. So set 3, 4 belongs to the set A. So this is true. Next I have solved sixth for you. Sixth is set 1, 2, 5 is a subset of A. Yes, because 1 to 5, the elements 1 to 5 are present in the set A. You can see that the elements 1 to 5 are there. So set 1 to 5 is a subset of A. It is true. Seventh is set 1 to 5 belongs to A. So this is false. Set 1 to 5 does not belong to A. Elements 1, 2, 5 are there, but set 1 to 5 is not there. So this is false. Remember the difference between belongs to and subset. 10th, we have 5 subset of A. Now this is true because 5 is subset of every set. So this is true. Set 5 belongs to A? No, because there is no set except 3, 4 belonging to A. So set 5 does not belong to A. Clear? So pause and solve the other parts. Next is question number 4. Write down all the subsets of the following sets. Write down all the subsets of the following sets. So I have solved the second part for you. The set is AB. Now since it has 2 elements, so number of subsets will be 2 power n. I told you the formula. So 2 power 2, that is 4 subsets will be there. So first, the individual elements, that is set A will be there, set of element B will be there. Every set is subset of itself, so set AB will be there, and phi is the subset of every set. So there are 4 elements. First is phi, second is the set of element A, third is set of element B, and fourth is the set itself, set of element AB. Clear? Phi and the set are there, then 2 elements are there, so one of that set, first element and second element. I am solving the fourth part, which is very simple. We have to find the subset of phi. Now the only subset of empty set is itself. Empty set means what? Number of elements is 0, so 2 power 0 is 1, so only one subset will be there. I hope I am clear. So pause and solve the other parts. Moving to question 5. How many elements has PA, that is power set of A, if A is equal to phi? Okay. Now if A is equal to phi, it means A has no element. Number of elements is 0. And the number of elements in the power set is what? 2 power n. So 2 power 0 is equal to what? 1. So if a set is empty, then the number of elements in the power set will be equal to 1. 2 power 0, that is 1. It is very simple. So pause and note down the solution. Moving to question 6. Write the following as intervals. Okay, I have told you about different types of interval: open interval, closed interval, open and closed from different ends. So this is the sum related to that. I have solved all the parts for you. Now first one is, if you look at this, minus 4 less than x less or equal to 6. It means minus 4 is open and 6 is closed. It is very simple. Open minus 4 and closed 6. Since minus 4 is not included and 6 is included. Second, we have minus 12 less than x less than minus 10. It means both minus 12 and minus 10 are not included. Okay, not included means open. So this will be open interval minus 12 comma minus 10. Remember the brackets. Open means small bracket, closed means square bracket. Third, we have 0 less or equal to x less than 7. So 0 is included but 7 is not included. So 0 is closed, 7 is open. Okay. Fourth is 3 less or equal to x less or equal to 4. It means both 3 and 4 are included. It will be closed from both sides. So closed 3, 4. Done? So pause and note down the solution. Next we have question number 7. Write the following intervals in the set builder form. Set builder form, if you remember, using the properties. So first is open interval minus 3, 0. Both the sides are open. It means both minus 3 and 0 will not be included. So it will be written as x, element x, such that x belongs to real number. And minus 3 is less than x less than 0. Clear? Both are not included. Second, we have closed interval 6, 12. So closed, it means both will be included. So we will write it as the element x such that x will belong to real number and 6 is less or equal to x less or equal to 12. Clear? Third, we have open 6, closed 12. It means 6 is not included but 12 is included. So this will be written as x such that x belongs to real number r but 6 less than x less or equal to 12. Clear? And fourth is closed minus 23, open 5. It means minus 23 is included but 5 is not included. So this will be written as x such that x belongs to r and minus 3 less or equal to s less than 5. Very simple. So pause and note down the solutions. Next is question number 8. What universal set or sets would you propose for each of the following? The set of right triangles and the set of isosceles triangle. Now while explaining, I have told you the universal set is what? That must contain all the elements of the given set. So here we have the set of right triangles. Now if I write the set of all the triangles, now set of all triangles will include acute angle, obtuse angle, isosceles, equilateral, scalene, right triangle, whatever is there. So all the triangles will be in the set of all triangles. So this set of all triangles will include right triangles and isosceles triangles. So that set, that is the set of all triangles, will act as the universal set for the set of right triangles and the set of isosceles triangles. Clear? So pause and note down the solution. Moving to question 9. Given the set A is 1, 3, 5, B is 2, 4, 6, C is 0, 2, 4, 6, 8, which of the following may be considered as the universal set for all the three sets ABC? Now we have four options, 1, 2, 3, 4. So universal set must contain all the elements of set A, B, C. So first we have 0, 1, 2, 3, 4, 5, 6. So it does not contain 8. So this cannot be the universal set. Second we have 5. So 5 does not contain element. So ये भी नहीं होने वाला. Third we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So all are there except, I think all are there, na? All are there, na? It means C will be the universal set. Okay, let's check fourth. We have fourth, that is 1, 2, 3, 4, 5, 6 and 8. So this set also contains all the elements except 0, because the set C contains 0. Clear? So we have which set? All are there in which all the elements of set A, B, C are in which set? Which set? Third one. So third one, that is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 will act as the universal set for the given set. Okay. So I hope I am clear. So pause and note down the solution. So with this we end exercise 1.3. So solve all the sums of this exercise, and also don't forget to solve the examples given before this exercise. Okay. Thank you and all the best.